Wireless lately has become a very popular type of network, and it is used almost everywhere in the world. So this is why what this chapter is basically concerned with. And so from the name of this course, which is Switching, Routing, and Wireless Essentials, we've done much of switching. The next two chapters will be for wireless, and then the last three chapters will be for routing. So let's kick this off. And the first thing I want us to note is just the objectives. What are we going to cover within this network? So we'll describe the wireless technology and different standards, the components of wireless local area networks, how wireless technologies enables the WLAN operations, how what is called WLC, the wireless LAN controller, and the CAPWAP used to manage multiple access points. Okay, control and provisioning for wireless access points. So that is the CAPWAP, control and provisioning for wireless access points. This is used. It's a protocol used together with a device called wireless LAN controller, WLC, to manage different access points or several or multiple access points. We'll describe the channel management within a wireless LAN local area network, and then we'll look at some threats, because wireless being very popular, it's been perceived to have some threats within it. It's been perceived to be vulnerable to threats. And then we'll describe some security mechanisms that are used to secure these wireless local area networks. And so to start us off, we need to talk about the benefit of wireless. And one of the most important benefits that wireless ever brought for us is the mobility. The mobility nature of wireless networks, such that you no longer have to be glued to a particular corner using an Ethernet cable to access the network. Gone are those days. Now you can use internet on the go. And using wireless technology, using our mobile devices, mobility has been the greatest kind of network advantage and benefit of having this wireless network. And so in different homes, different offices, campus environments, we have this wireless infrastructure. And this wireless network is adapting very rapidly to various changes within the work environment and within different types of environment. Now, it's important to note that there exist different types of wireless networks, and one of those types is called the wireless personal area network, what is called the WPAN or WPAN. Now, the wireless personal area network, or the WPAN, is the network that is composed of Bluetooth. So Bluetooth falls under the WPAN, wireless personal area network, and the specific standard within IEEE is 802.15. So every time you hear about 802.15, just know that this is the standard where Bluetooth exists. And it uses low power, that is Bluetooth, and it only covers a very short range, that is between 20 to 30 feet, which is about 6 to 9 meters. Okay, and it only utilizes the 2.4 gigahertz frequency, because normally for wireless networks we have two frequencies. It's either 2.4 or 5.0 gigahertz. So Bluetooth only works with 2.4 gigahertz. And Bluetooth has been, we've been having different versions of Bluetooth. And the latest development within these wireless personal area networks is what's called ZigBee. And ZigBee generally came because of IoT. IoT require less power, but very low bandwidth and still be able to do its job. And then, apart from Bluetooth, under the WLAN, we have what is called the WLAN, the wireless local area network, the WLAN. And this is what is popularly known as the Wi-Fi. This is what we call Wi-Fi. And it's a medium-sized network that covers slightly an extended distance of about 300 feet. And this one can cover both frequencies, either 2.4 gigahertz or 5.0 gigahertz. And the IEEE standard for this one is 802.11. IEEE 802.11. So the other Bluetooth was 802.15. This is 802.11. And then apart from WLAN, we also have what's called the WMAN, the Wireless Metropolitan Area Network. This is a wireless network that covers a larger geographical area, can be within a city or within a district, and it must use some licensed frequency, not specific ones, okay? And so there exist cities that have a wireless network. The moment you get to the vicinity of the city, then you can turn off your data bundles and you can now be able to use the metropolitan area network. This is a wireless network within a city or a district. Just to mention a few, we also have what is called the WE1, the wireless wide area network. And this is an extensively, a wireless network that covers a larger geographical area. This could be within the national or, within the country or for global communications. And even these ones uses specific licensed frequencies. It does not have specific frequencies. So the frequencies have to be licensed. Now, those are just but a few, but we do have, want to talk about some of them specifically. For example, talking about Bluetooth, which is the weapon, which is normally used for pairing devices within a distance of about 300 feet, which is equivalent to 100 meters. And we do have the Bluetooth Low Energy, the BLE. It supports mesh topology to large-scale networks devices. So the BLE is the first type of Bluetooth. Then we have what is called the BR/EDR, the Bluetooth Basic Rate/Enhanced Rate. This is the one that supports point-to-point topologies, and it's optimized for audio streaming. So this is the one that is commonly used. Most mobile phones normally have this type, the second type. The first type is the one that can actually be able to pair more than one device. More than one device can be paired within the same Bluetooth network. And then we have what is called the WiMAX, the Worldwide Interoperability for Microwave Access. This is an alternative broadband wide network connection. Normally, the IEEE standard is 802.16. And this covers a larger geographical area. It is also a wireless connectivity option, covering up to about 30 miles. That's about 50 kilometers in length. So just different types of wireless networks. I know that the cellular or the mobile phone network is very popular. And so this type of network is the one we call the cellular broadband. And it's become very popular, and it's been growing with reference to generations. So we did have second generation, we went to third generation, what we call 3G. Then we went to 4G, fourth generation. And now we are at 5G, which is the fifth generation. And it's used by mobile phones, automobiles use it, tablets and laptops still use this type of network. And it uses these two modes. We have the global systems of mobiles, GSM, which is internationally recognized. But the second one, the CDMA, which is primarily used in the United States, the core division multiple access. So that is a cellular network, or a cellular broadband network. And the word cellular comes from the cell towers. Cell towers, which interconnect, like the one shown on the right, to be able to provide connectivity to devices from different parts. And then we have one of these other one called satellite broadband. So satellite is a very interesting connectivity option. And so for either it's organizations or people who need to connect to the internet, but these people do not have any other type of connectivity. Either these people could be on an aeroplane in the sky, or these people could be within the desert or in the water, all right, or some remote place. Satellite, so long as it's put in such a way that the satellite dish within that area needs to have a clear line of sight with the satellite dish in space, and that clear line of sight is very, very important for it to have some basic wireless connectivity. It might not have very serious speeds, but it will be basic, for you to do some light browsing and checking over your emails and answering some messages on WhatsApp, for example. All right. Our study is going to pay more attention to the Wi-Fi, which is the wireless LAN. And we first start by talking about the standards, different standards. We have different standards. Since it is 802.11, we have different standards of 802.11 from IEEE. So we have 802.11 itself, which uses a 2.4 gigahertz, data rates of up to about 2 Mbps. We have 802.11a using 5 gigahertz, data rates up to 54 Mbps. 802.11b, 2.4, rates of up to 11 Mbps. 802.11g, 2.4 gigahertz, data rates of up to 54 Mbps. And you realize that some of them are backward compatible, while some of them are not. Okay. Backward compatibility means, they can coexist with the other standards. Then we have 802.11n, 802.11n, which uses, and this is important, 11n you can see, and 11ax, they use both 2.4 and 5 gigahertz. And 11n uses from between 150 to 600 Mbps of data rates. And 11ax uses what's called the HEW, the high efficiency wireless, which is capable of using 1 gigahertz and 7 gigahertz frequencies. Otherwise, 802.11 AC, which uses 5 gigahertz, just like 11A, have data rates between 450 to all the way to 1.3 gigabits. And it supports up to about 8 antennas normally. So again, you don't have to cram these ones. You just need, for a point of information, that we do have different standards for our wireless local area network. Now, because the wireless network travels over electromagnetic waves, they do have some radio frequencies, And so all wireless devices in the range of electromagnetic spectrum, and they operate either in 2.4 or 5 gigahertz frequency bands. And so we have other gadgets as well, and other types of electromagnetic waves, from the radio waves used by the cellular networks, used by the, radio cassette, a TV set, microwaves, and some of these satellite dishes, including these other ones here. But from radio waves, we move towards infrared. Infrared is majorly used by if you have a remote control gadget. And then we go to ultraviolet, majorly used for lighting. And as you move on, by the way, they get to become more and more harmful even to the human health. And so waves like the X-ray used within the medical field, and the X-ray, they have some level of harm, especially if you have to do it severally. It can interfere with body functionality. When you move towards gamma rays, and those become more and more harmful to humans. And so basically what we are trying to do is just to tell you the different frequencies. Some of them are high frequencies, which are not safe for human beings, okay? Now, what composes or what poses a wireless network? Within a wireless local area network, the following things are very important. Number one, we need to have what is called network interface cards, network interface card adapters. It's only any device that needs to access a wireless network must possess an NIC, okay? And so because they are accessing a wireless network, they must possess a wireless NIC. That therefore means that we also have wired NICs. We also have wired NICs. And so laptops, tablets, smartphones, and any latest automobiles, they must have integrated NICs that incorporate a radio transmitter and receiver for these signals, okay? And so any device that doesn't have an integrated version of these NICs can still be modified by just, acquiring a USB wireless adapter, which you plug it on the USB port of devices, and they'll definitely be able to connect us to the wireless network. Very, very important. So apart from these devices having NICs, we also must have a wireless router within our midst. And a wireless router, the fact that it is a router, it means it can connect our LAN to another network, for example, to the internet, okay? And wireless routers are very powerful, normally used in homes and small offices. Even bigger offices use wireless networks. They function as access points to provide wireless access to end devices. They also work as a switch because they come with about 4 Ethernet ports, which can be used to connect, wired devices like desktop computers and all that. They also work as a router because they act as our default gateway to reach other networks and the internet as well. Of course, it goes without saying, they act as DHCP servers and DNS servers as well. Now, for an access point, the most wireless devices or clients will use their wireless NIC to determine any access points nearby. And the clients will attempt to associate itself with and authenticate with a certain access point. And once it is authenticated, the users can now have access to the network resources, Now, access points can always be categorized, whether as autonomous or controller-based access points. And so let's start with the autonomous. An autonomous access point is basically an access point which is, configured and managed through the graphical user interface of its own, and it acts independently of other access points that are found nearby, okay? So if you have internet in your house, in most cases, there must be, it normally is a wireless router But you can also have an access point, which provides internet connection to just a small group of people. And this is a very common one, mostly for small scale usage, like in offices or in our houses or in homes. But in big organizations, where there are so many access points, they will always want to manage the access points in one place. And so the gadget that is used to manage this access point is called the wireless LAN controller. The LAN controller. Okay. And so this controller-based access points are also known as lightweight access points. And they work under a protocol called the LWAP, the lightweight access point protocol. Basically to communicate with the controller. And each LAN access point or lightweight access point is normally automatically configured and managed by the LAN controller. Now, autonomous and controller-based. Autonomous is standalone, works by itself. Controller-based, they must be controlled by another device. Because they always have antennas, we do have three types of antennas. We have what is called the omnidirectional, like omnipresent, omniscient. The word omni is related to just one. And so, actually the word omni means not one, because one is, directional. Omni means any direction. So these ones provide a 360-degree coverage within an area. And these are antennas that are very powerful and very ideal for houses and offices because of that degree of coverage. Then we have directional antennas, which focus on a specific direction. Okay. And example can include the Yagi and the parabolic dishes. Yeah, so this is a very good example of the Yagi, the parabolic dishes. That's with an access point there. This is the omnidirectional one here. Okay. Then we do have the third one called the multiple input, output, multiple input, multiple output, the MIMO. The MIMO is only identified by having multiple antennas, normally up to about 8. And you could be able to see that if you're keen enough. And you can see this has several antennas that we actually seeing here. Okay. So that is different types of antennas within our network. Let's talk about now the operation of the wireless network. Now, there exists these three topology types within a wireless network. We have the ad hoc mode. The ad hoc mode basically is used to connect LANs in a peer-to-peer manner without an access point. You can see a very good example is just connecting two devices without any access point. So they might connect to their own networks and they might not be using the Wi-Fi network, but it is an ad hoc topology mode. Then we have the infrastructure mode. This is the most common one. This is where we have an access point, or a wireless router, which connects us to the internet. Then we have what's called tethering. And so for the tethering one, if you have ever created a hotspot on your phone, that's a very good example of tethering topology for wireless network. Now, it is important to note that there are two terms here, the BSS and the ESS. The BSS and the ESS. Now, the ESS normally, which is the BSS, which is the basic service set. This is a situation whereby we do have just a single access point to connect all the clans. okay, we do have one access point which is connecting all the wireless clients. Okay, and even if there are different access points within the same area, they work so independently and they cannot communicate to each other. Then we have what is called the ESS, the extended service set. We know that each access point normally has a unique name, and the name is called an SSID, service set identifier. And so in an ESS, we unite two or more, BSSs using a wire distribution, and devices from one access point can actually communicate with devices in another access point. So we extend, services of one access point to the other access point so that they are able to communicate. They are able to communicate. So that is what's called the ESS, the extended set. Now, these terms here, I know we have talked about them within the first module, the CMS/CA. We also have CSMS/CD, but because we are talking about wireless networks today, we are going to talk about the carrier sense multiple access with collision avoidance. The carrier sense multiple access with collision avoidance. We know that wireless networks work on half duplex, and that's why half duplex is like you have one highway which can only be used by one vehicle at a time. You have a highway which can only fit one vehicle at a time, which means only one vehicle can move in one direction. When the other one goes and branches somewhere, then another one can come, which means in half duplex, only one device can send or only one device can receive. We cannot have a device sending and receiving at the same time. So it is impossible to detect a collision because a client cannot hear while it is sending, making it, of course, impossible detecting any collision. So we use this collision avoidance of the carrier sense to determine how and when to send data. And so this is the sequence that normally happens, and the reason I'm going to describe here is what makes a situation whereby when you are having a wired network using Ethernet cable, the more people joining that network, you might not even realize that there's a slow performance. There's no slow performance of that network if more people join and they're given Ethernet cables to connect to the network. But when you are using a wireless network, the more people joining a wireless network, the slower it gets. The more people joining a wireless network, the slower it gets. And this is the reason why. Now, since only one device can send at a time, every client or a client that needs to use the channel is going to be listening on the channel to check if it is idle. That means no other traffic is currently on that particular channel. Once it does listen and there is actually no device utilizing the channel, that client device is going to send an RTS message, ready to send message, and it's sent to the access point or the wireless router. Because it is sending a ready to send message, requesting for its own dedicated time of access to the network or time of usage to the network. Now, when it sends a ready to send, or some people call it request to send, the access point sends back to this client a clear to send message from the access point, clear to send, which is going to grant this device to actually utilize the message. Now, when the ready to send or request to send message is sent to the access point, it is also sent with a particular duration of time, such that when the access point is sending back a clear to send message, that message is also shared with other devices, other wireless devices in the network, notifying them that the network is going to be unavailable or the network is going to be unavailable for use for a random period of time. Okay, and the process will be restarted if no clear to send message is ever received. So the idea is for only one device to be using the channel at a time. Okay, so you send a message to the access point, tell the access point, I'm going to be using the network within the next 2 microseconds. All right, and that message, everyone is going to get it. And once the device has requested that dedicated access, it's going to transmit, and it is going to acknowledge all transmissions. And if the wireless client does not receive any acknowledgement, it will assume a collision has occurred and restart the process. So this is what's called the carrier sense multi-access with collision avoidance. It doesn't, like we are told, detect any collision, but it's important to note how is it that, and it's happened so quick that these devices are not even able to note that. Now, what happens when a wireless client, like your mobile phone, wants to access a wireless network? All right. So for them to communicate to that network, they must first do what? The first thing is to associate with the access point or your wireless router. So to associate, it needs to first discover the wireless access point. By, of course, you'll be able to see the name or the SSID, the service set identifier. Okay. Then once you've discovered the name of that particular access point, then it will ask you to put in some password. And that means you'll be authenticating with the access point. When you put the correct device, then the device will associate. Your end device will have to associate with the access point, and that is the sequence. Discover access point, authenticate with it, and then associate. And in the process of the association, IP addresses are acquired, and this device is actually ready to go to access its the services within the network. Now, upon successful association, a wireless client and the access point must always agree on a certain parameters here. One, they must agree that they're using the same SSID. So the client will need to know the name of that network, and that's what you're calling the service set identifier. Then the client must know the passwords. This is required for authentication with the access point. In most cases, the network mode is always set. So this one has not so much. The network mode, is it 802.11 standard or is it 802.16, so on and so forth. Security mode, again, these ones are always set by default, and we're going to talk about them. The WEP, WPA, or WPA2, and we even have WPA3. Then channel settings, again, these frequency bands are always set automatically, and in most cases, we don't even get to worry about them. Now, the SSID can always be in two forms. It can be in passive mode or it can be in active mode. Okay. An access point operating on passive mode is the one that openly they advertise their name periodically. They keep on sending that beacon and advertise it to any network within any device within the area. Whether you know the password or not, you'll always see the name of the wireless networks through the SSID. The active mode is whereby the client doesn't know the specific SSID, and the client has to be informed, okay? Or you must know the exact name of that SSID, and you enter it manually. Then you enter the password manually, and that is always done to protect the network. Some people hide the SSID, or they clock it to prevent people from even knowing the name of that particular wireless network. And we will talk about the SSID. Now, in terms of management and operations, if you have so many access points within the network, you need this protocol called the CAPWAP, the control and provisioning of wireless access points. control and provisioning for wireless access points. This is the protocol that is used to manage the communications between the end device and the access point and the access point. And the access points are actually managed using a device called a wireless LAN controller, WLC. And so for CAPWAP, very, very important. There do exist something called the MAC, the split media access control architecture. For encryption of traffic between the LAN controller and the access points, we use DTLS encryption. And then, of course, we do have the Flex Connect access point. Now, looking at this particular diagram, you can see that we do have a wireless LAN controller, which is being used to manage different access points here, okay? And so this access point, as you can see here, we have access point 1, we have access point 2 here, okay? And then we have access point number 3. So each of them is being managed by the LAN controller, what's called the wireless LAN controller, and realize that each is managed through a protocol called the CAPWAP, the control and provisioning for wireless access points. And all those access points can actually be managed just from the WLC. They can be configured, their details could still be able to be seen. Now, to provide some level of security within the CAPWAP, the datagram transport layer security, DTLS, is always used to, provide some kind of encryption within the CAPWAP channel. And so it is important that, these channels can be used over both IP version 4 and version 6. And, basically managing more than one access point. Now, in terms of channel management, it is important to be able to, it is important normally to be able to manage different channels, especially this comes in places where buildings are involved. So when buildings normally are involved, you need to manage during the construction phase, check on the construction materials, check on where you're going to have your access points, okay, available. And so this is going to ensure that, you're not going to be having different obstacles for your wireless networks, okay? And so check the geographical layout of your facility and, of course, how many users will be there and which devices will fit within that space and which data rates are expected, okay? And there do exist what's called the overlapping and non-overlapping channels. So the overlapping channels are actually wireless channels which can interfere with the functionality of the other channel. But non-overlapping ones are ones that can coexist with other channels within the same location. You can find that your neighbor is having a wireless network of their own at a different channel, and you have a wireless network at a different channels. If those two channels are overlapping, then either one of you or both of you are going to experience connectivity problems. But with non-overlapping channels, those ones, they can actually coexist and you can use them anywhere. Now, in terms of threats within the network, there do exist several threats within the network, okay? Because the wireless waves are always open to anyone, the electromagnetic waves, anyone within the range of the access point. And then what they normally need is just some credentials to associate with it. Attacks could always be, instigated by outsiders or even employees, or unintentionally by your employees. And so wireless networks are very vulnerable to several threats. And so data could be intercepted. You'll have wireless intruders, people who just come to intrude on your network. You could have what's called the DDoS. Someone can perform a denial of service attack, which prevents the users from having access within the network, And so it is important to note that we need to always protect our wireless networks. And there are people who have also created what is called the rogue access point. These are fake access points where someone creates an access point which is fake. They give it the same name as the name of your access point, and it's actually free. Normally, it doesn't have any passwords. And so the moment you join that network, you might think you're joining the authentic network, yet you join a network that is not actually authentic. And so someone end up either stealing your data, or they can even steal your passwords. Maybe you are trying to log into your online banking, and they can be able to capture all that traffic and get those credentials and log into your network. And that is not something that you have to do. And that's why things like banks, when you're doing online banking, they have very strict regulations for multi-factor authentication. For multi-factor authentication, either you have to send a code on your mobile phone or to another email address, just to prevent some of these data interception attacks. People who have hacked into other wireless gadgets, and they're able to change the passwords, and they're able to deny everyone else access to the network. That is a very good example of denial of service attacks. Now, how can we be able to mitigate against some of these attacks here? We need to secure our wireless local area networks. And one way of securing our wireless network is by doing what is called an SSID clocking. SSID clocking is whereby you decide to actually disable your access point or your wireless router from advertising the name, the SSID of your device. Okay? So that you have a network, a wireless network actually, but nobody sees that name. Nobody, when they try to search for the name of your access point, they can't see it. And so you give them a very tough job. They might think you don't even have a wireless network. So they must know two things. First, they must work very hard to know the name of your network, the SSID, service set identifier. Then after they know the name, then they must know the password. And that is a very good security mechanism for your wireless network. So if you do have a Wi-Fi and you know that you have neighbors within your quality that you cannot resist, or you have some visitors or some people who during the weekend, they just want to come and use your Wi-Fi the whole day. And so one of the measures, basically to control your network is to enable SSID clocking, all right? So that someone has to manually enter their name and the password. And then we do have what's called the MAC address filtering. Now, in MAC address filtering, this can be, compared with what is called blacklisting. Like on your mobile phone, you can blacklist a certain number so that that number can never call you. So that is what we call a blacklist. So since every gadget that connects to a wireless network through the access point or the wireless router records the MAC address of each and every device. And so what you could do, and of course it records the MAC address plus the IP address it's been given. So what you can do is that you can actually blacklist some of the MAC addresses which are foreign to you, so that people who connect to your network, they might have the password or even the SSID. They might even authenticate very successfully. All right, they put the correct name, they put the correct password, but and it connects very well, but when they try browsing, they can never browse. And you do that by doing MAC address filtering. And you can also be able to put them in a whitelist. It's not just a blacklist. You know that a blacklist, people cannot access you. And only the people in the blacklist can't access you. Everyone else can access you. That's a blacklist. Now, the opposite is called a whitelist. In a whitelist, only those in the whitelist can access the network or can access you. Anyone else who is not in the whitelist is like they're in the blacklist and they can never access you. So blacklisting is a feature that is normally used with MAC address filtering. You filter the specific MAC address, and it's a very interesting one. You don't deny people from getting the SSID, and you don't deny them from getting the password for your Wi-Fi. But you be very smart, and you actually filter their MAC addresses, and they will never know that unless they've been to such a class. Now, in terms of authentication methods, we do have two authentication methods. Now, the best one is always to use authentication and encryption systems. But we do have two methods. The first one is called the open system authentication. This method is mostly used in hotels, airports, cyber cafes, or even caves. And these are wireless networks without any password, okay? And they are typically used to provide free internet access in public areas, okay? And normally the client is responsible for providing security of their own. Like the client must have a VPN of their own or something like that. So this is where, you know, you are in charge of your own security. You're in charge of your own security for this particular wireless network. Now, the other method of authentication is actually what is called the shared key authentication. In fact, this is where it has a password, and you do have what's called the pre-shared key, all right? And so you must give someone the password in prior before they can be able to join the network. So this one uses these protocols, security protocols for encryption. We have the WEP, WEP, we have WPA, we have WPA2, and even WPA3. WPA3 is the latest one. They're used to authenticate and encrypt data between the wireless client and the access point. So the password must be shared between these parties, for them to be able to connect to the network. And we will be talking about those methods of authentication. Let's start with the weakest one, and is the oldest one, and it's a legacy one. We call this the WEP, the wired equivalent privacy. So the wired equivalent privacy, this is the original specification, but it's no longer being used because it's not recommended at all security-wise. And it uses the RC4, the reverse cipher for encryption method with the static key. So we don't recommend it, and most networks rarely use it. Then we have the second one, which is called WPA, the Wi-Fi protected access, which normally uses a much stronger key, the TKIP, the temporal key integrity protocol encryption algorithm, which changes the key for each packet, and it makes it much more difficult to hack into. But this was WPA version 1. We strongly discourage it, and most networks currently, they use version 2, the Wi-Fi protected access version 2, which uses a technology or an encryption algorithm called AES, the encryption advanced standards, the advanced encryption standards, and is currently the strongest encryption protocol available. But because of developments in technology, we do have the WPA3, the Wi-Fi protected access version 3. This is the next generation of Wi-Fi security, okay? And it's one of the latest security methods. And this method here, we're going to learn about some of its features. And it's more and more secure, and it protects, it offers more protection than even version 2. So let's talk about something that you might have seen it if you have logged into a wireless device. If you log into a wireless device, normally you just log in on your browser using an IP address that is normally provided. And then you put a password. So either using WPA or WPA2, you always have two functions. You can either choose WPA or WPA2, personal or enterprise. And so what is the difference between personal and enterprise? And you can see normally when you log in, it actually looks something like this. You can use the WEP, or you can choose WPA, personal or enterprise, or WPA2, personal or enterprise. So my question is, what is the difference between personal and enterprise? Now, personal is basically used in small homes, or I mean within our homes, or small office networks, where users, they authenticate using the password, what is called the pre-shared key, the PSK. Okay. And so this password is created within the wireless router, and there are no special server that is required, because basically this is used within an area that has very few users. Within an office, you expect to have just few people, or at home, we just have the members of the family at home. And everyone who needs to connect to the network will ask, what is the Wi-Fi password, something like that. Now, we do have what is called an enterprise, WPA or WPA2 enterprise. This is majorly used in large organizations where there are thousands and thousands of people using the wireless network, right? And like I told you, within an enterprise network. And so you cannot be able to control all these people by them logging or them using the password that is stored on the wireless router. And so what they do is that they use a protocol called the radius, the remote authentication dial-in user service, which is an authentication server. And every device must be authenticated by this server. And then the users must also authenticate using the 802.1x standard, which we did talk about, I think, yesterday. So 802.1x can also be used on wireless networks. And 802.1x uses something called the EAP, the Extensible Authentication Protocol. So it's a very it's a very very important one, especially for managing large groups of users. For managing large groups of users. For managing these large groups of users. And so I've gone to one of the telecommunications companies like Safaricom. They have these large groups of users. Universities like Kenyatta universities and different universities, they also manage, since they have students there, they manage that large group of people, by ensuring that they implement the enterprise type of network. Now, it's important to note between these two encryption methods, the TKIP, the Temporal Key Integrity Protocol, was used by WPA version 1, and it provides support, but for legacy LAN equipment. Now, the make use of web, but it encrypts the layer 2 payload using the TKIP. Now, this is not very secure, and that's why the latest encryption is actually the AES, the Advanced Encryption Standards, which is normally used by WPA2, and it uses something called the CCMP, the counter cipher mode with block chaining, message authentication code protocol, which allows the destination host to recognize if the encrypted and non-encrypted bits have been altered. So, I mean, it's about cryptography and all that, but this ensures some level of security within the wireless networks, because if you don't take care of your wireless networks, there's gonna be a problem. Now, at the enterprise level, and by the way, we will be making during our next class, we'll be making configurations, for enterprise. And so the enterprise security mode choice normally requires the AAA radius server, the authentication, authorization, and accounting. And it requires 3 pieces of information here. The radio server must have an IP address. Then it must select these UDP port numbers, 1812 for the radius authentication, 1813 for accounting, but it also operates using the UDP port 1645 and 1646. Now, it must also have the password itself, the pre-shared key, which is used to authenticate with the access point with the radio server. So an end device wants to connect to the network. So it puts the pre-shared key, which is sent to the access point, and the access point will send it to the radio server. Okay. To the radio server, and the radio server will authenticate by confirming if those credentials that are entered are actually correct. Okay. Now, the authentication, of course, and the authorization will be handled by an 802.1x standard, which will provide a centralized server-based authentication for the particular end users. Now, being the latest mode of technology, WPA3 is a very, very, very important one, and it is important, that we do talk about this WPA3, the Wi-Fi protected access. Now, the reason why we have WPA3 is because WPA2 is no longer considered secure, and that's why we recommend strongly that WPA3 be used whenever possible. 4 features that we have for WPA3. 1, WPA3 can be used to prevent a brute force attacks. You know what a brute force attack is? A brute force attack is an attack whereby the hacker tries to keep on guessing the password continuously using different password combinations. Yeah? And so to prevent against a brute force attack or to thwart brute force attacks, WPA3 uses what is called the SAE, the SAE, the simultaneous authentication of equals, simultaneous authentication of equals. All right. And that's a very common question for your exams. Which feature is used by the WPA3 to protect against brute force attacks? That is the SAE. Then WPA3 is available, of course, for enterprise networks. And it uses the 802.1x/EAP, okay? The extensible authentication protocol for authentication. But this requires the use of 192-bit cryptographic suite, which eliminates the mixing of security protocols. And this is for other previous 802.1 standards. Yeah, that's for enterprise. Now, 2 more features of a WPA3 is that WPA3 has what is called the open networks, whereby there is no authentication that is required. That is, there's no password that is available there. However, all the traffic will be encrypted using what is called the OWE, the opportunistic wireless encryption. Opportunistic wireless encryption. So there's no password required, but all traffic is actually encrypted using the opportunistic wireless encryption. And this is a very good thing for our network. We are doing away with, you must always use a password for authentication, kind of here. But, we are also talking about IoT onboarding here. Very, very important. And so for the quick onboarding of Internet of Things devices, we have what is called the DPP, the Device Provision Protocol, which provides a mechanism to quickly onboard our IoT devices within the network. And that is very, very important for us to note. And so having talked about wireless networks, we've talked about how it operates. We've talked about the components of a wireless network. We've talked about the different standards and channels that are available within a wireless network. And we've talked about the different authentication encryption protocols. And we've talked about different authentication protocols, levels from WEP to WPA, WPA2, and now we talk about WPA3. And you know that wireless is growing to become more and more advanced as time moves by. And so I think that is the end of this particular class. We shall be talking about tomorrow. So in preparation for tomorrow, that is, tomorrow, the wireless network normally does not have much outdoor practical, but most of it requires some kind of, logging into a particular device, using an IP address and using the passwords and usernames. And so what we are going to do, the better part of tomorrow will be configuring packet tracer activities of wireless networks and trying, to configure even a AAA server within it. Some of these things are not available in real life, within the Academy for Learning. And so Cisco provides so many packet trace activities so that you can at least get comfortable with configuring wireless networks, because a wireless network is very secure. And so it's important that tomorrow we be ready for that activity, just to majorly be able to get up to date with this particular wireless network. Otherwise, I think that marks the end of our meeting today. Let's meet tomorrow at 5